Problem number 6, we have a volume of 450 cubic centimeters of air is measured at a pressure of 740 mmHg absolute and a temperature of 20 degrees Celsius. What is the volume in cubic centimeter at 760 mmHg absolute and 0 degrees Celsius? So volume in cubic centimeter, this is our final volume. So the relationship, this is a process, so P1 V1 over T1 is equal to P sub 2 V sub 2 all over T sub 2. Okay, manipulating this equation, V2 in terms of other properties, so we have P1 V1 over T1, we have times T sub 2 all over P sub 2. So we just get that relationship in terms of V sub 2. So P1 here is given by 740, okay, at pressure 1 is 740 mmHg, that is millimeters of mercury. Then P sub 2 is equal to 760 millimeters of mercury. Then V sub 1 is given by 450 cubic centimeters. T1 as 20 degrees Celsius, so that is 20 plus 273. So Kelvin siya because this should be in absolute. So this value is equivalent to 293. This is Kelvin. Then our temperature 2, okay, T sub 2 is equal to 0 degrees Celsius. So 0 plus 273, convert that to Kelvin. So this is 273 kelvins. Then we just need to substitute all of these values. Then V sub 2 is equivalent to P1 V1 over T1 times we have T2 all over P sub 2. So we just need to substitute that. So P1 here is 740 millimeters of mercury times V sub 1, that is 450 cubic centimeters times T sub 2, that is 273 Kelvin, then all over we have T1, that is 293 Kelvin, then P sub 2 is 760 millimeters of mercury. So we have here a unit of volume which is cubic centimeter kasi ito mag-cancel na yung mga units niya dito. So cubic centimeters. V sub 2 is 408.25. So 408.25, this is in cubic centimeter. So this is our final answer for number 6. So we have here our 7th problem. What is the density of dinitrogen monoxide, that is N2O, at a temperature of 325 Kelvin and a pressure of 113 kilopascal? So notice this problem guys, hindi tayo binigyan dito ng gas constant of this dinitrogen monoxide, pero pwede natin siyang mahanap using the universal gas constant. Okay, so ito equation of state lang. Wala tayong process dito. Hinahanap lang natin is the density of this compound here. So PV equals mRT. So from our concept that density is your mass per unit of volume of that substance. Okay, so let's extract M over V from PV mRT. So from this equation, we can say that M over V is equal to your P over RT. Okay, so this is density. Now we can say that density is just equal to your pressure all over your gas constant times the temperature. But here, wala tayong gas constant. But from our concept before, gas constant is equal to your universal gas constant divided by the molecular weight of that specific gas. Okay, hanapin natin yung gas constant ng N2O. So N2O, dinitrogen monoxide. So the R of the N2O is equal to the universal gas constant all over the molecular weight of N2O. So that is equal to, so etong problem natin is naka-SI. So gagamitin nating universal gas constant is the SI units. This is 8.314 kilojoule per kilomole Kelvin. divided by the molecular weight of N2O. So the molecular weight of nitrogen is just the sum of the molecular weight of each constituent element. So nitrogen dito, times 2 siya, diatomic, may subscript na 2. So times 2 here, then times the molecular weight of nitrogen. So that is 14 kilograms per kilomole. So ginawa natin kilograms guys. So kilograms per kilomole. Para mag-cancel, para maging consistent yung unit natin dito sa kilomole. So it's either grams per mole or kilograms per kilomole. It's the same thing. So plus, so ito oxygen isa lang, so times 1, 1 yung subscript niya, times its molecular weight, that is 16 kilograms per kilomole. Then we just get that gas constant of dinitrogen monoxide. So R of N2O is equal to, just need to solve this. Ang unit niya is kilojoule. Kilomole will cancel, so kilojoule per kilogram Kelvin. So this is 0.189 kilojoule per kilogram Kelvin. Okay na. So we just need to apply this concept here. So the density is equal to pressure divided by RT. Okay, so pressure is 113 kPa. So pressure is 113 kilopascal divided by its gas constant. So that is 0.189 kilojoule per kilogram Kelvin times the temperature, which is 325 Kelvin. So dito unit analysis tayo. So dito mag-unit analysis tayo guys. So kPa equivalent unit niya is kilonewton per square meter. So kilonewton per square meter. So yung kilojoule is kilonewton meter. So equivalent unit niya yan. So cancel na yung kilonewton here, will cancel out. We have Kelvin here. Then yung meter dito, multiply sa meter square dito. So that will become cubic meter. Then ang unit natin, so itong kilograms, ilalagay natin dun sa taas to simplify. So ang unit nito is kilograms per cubic meter. So that is a density unit. So density, so lagyan natin ng denotation. So density of dinitrogen monoxide is equal to, so you have 113 divided by this RT. So the density of dinitrogen monoxide is found to be, we have 1.84, that is kilograms per cubic meter. So this is the final answer for this problem. This is number 7. So we have still 3 more problems to solve. Next problem, we have here, assuming air to be an ideal gas with a molecular weight of 28.967 kilograms per kilomole. What is the density of air at 1 atm and 600 degrees Celsius? Okay, density ang hinahanap natin guys. So PV equals mRT. Okay, so density, from the concept that density is your mass per unit of volume. Okay, extract natin siya dito. So M over V equals P over RT. Okay, so this is just equal to your density. Ang given natin dito guys is your molecular weight. So itong gas constant, our gas constant can be expressed as your universal gas constant divided by its molecular weight. So if density is equal to P over RT, let's just first solve for its gas constant to find this density. So ang pressure natin is given by, we have here 1 atm. So by conversion, yung 1 atmosphere, that is standard pressure at sea level, you have here 101.325 kilo Pascal. So yung temperature natin is in degrees Celsius. So conversion natin is temperature equals, so the degree Celsius temperature 600, mag-add tayo ng 273 to convert that to Kelvin. So this is equal to, we have here 873 Kelvin. So going back to our gas constant, so that is your universal gas constant divided by its molecular weight. So universal gas constant SI units is 8.314, that is kilojoule per kilomoles Kelvin. Okay, divided by its molecular weight. From the given, the molecular weight is 28.967. So 28.967, that is kilograms per kilomole. So ang unit natin dito guys is kilojoule per kilogram Kelvin. So kilomole will cancel out na dito. So cancel na yung kilomole. Unit natin here is kilojoule per kilogram Kelvin. So R here is 0.287. So we can assume that this is air. So 0.287 kilojoules per kilogram Kelvin. So density equals, we have pressure over RT. So pressure natin atmospheric, so 180 m, so 101.325 kilopascals divided by RT. So 0.287 kilojoule per kilogram Kelvin times yung temperature natin, that is 873 Kelvin. So unit analysis natin, so kilopascal is kilonewtons per square meter. So kilonewton per square meter. Then etong kilojoule can be expressed as kilonewton meter. Okay, kilonewton meter. So kilonewton here will cancel out. Okay, so we have here Kelvin cancel out. So yung square meter mag-multiply sa meter here. So yung denominator niya is cubic meter. Yung kilogram natin lalagay natin sa taas to simplify. So ang unit niya is kilogram per cubic meter. So that is density. So density of this gas is equal to, the density is equal to 0.4. Okay, 0.404. This is kilograms per cubic meter. This is the final answer for this particular problem. So this is problem number 9 guys. So 48.5 pounds of ammonia is confined inside a cylinder equipped with piston, has an initial pressure of 60 psi at 100.4 degrees Fahrenheit. What is the volume of the ammonia inside the cylinder in cubic feet? Okay, so ito ammonia. So the chemical formula for ammonia is NH3. So this is ammonia. Now we are going to find the volume of this ammonia. So gamitin lang natin yung equation of state. So PV equals MRT. So V yung hinahanap natin, therefore V is equal to MRT all over pressure. Okay. So identify muna natin yung mga given. So pressure is given as, initial pressure niya is 60 psi. Okay, absolute na yan. Then our temperature is given by, so temperature is equal to 100.4 degrees Fahrenheit. So i-convert natin yung temperature to Rankine. So temperature equals, so 100.4 degrees Fahrenheit plus 460, that is now in Rankine. So this is 560.4 Rankine. So yung mass natin is given as 48.5 pound of mass. So hanapin natin guys, so M is given here, temperature given, pressure is given, wala tayong gas constant. And here we have the concept. So yung concept natin for the gas constant, so gas constant of ammonia is equal to the universal gas constant all over the molecular weight of ammonia, NH3. The universal gas constant, gamitin natin yung English unit, so that is 1545 foot-pound force. So that is per mole Rankine. So divided by the molecular weight of NH3. Okay, so N, nitrogen yan. So 1 lang, subscript niya is 1. So we have here the molecular weight of nitrogen, that is 14 pounds per mole. Okay? Add natin yung molecular weight ng hydrogen, so that is 3. So 3 times, that is 1 pounds per mole. So i-divide lang natin yan. Ang unit natin dito is foot-pound force per pound mass Rankine for that gas constant of ammonia. Gas constant of ammonia is given by 90.88, that is foot-pound force per pound mass Rankine. Then let's find the volume. This is the final answer. So V is equal to MRT over So yung M natin from the problem, that is 48.5 pound mass. So mass is 48.5 pound of mass times R natin, that is 90.88, that is foot pound force per pound mass Rankine. Then temperature natin is given as 560.4 Rankine. So that is divided by the pressure. So yung pressure natin is 60 psi. Okay, so divided by 60 pound force per square inch. So notice here na naka-foot siya dito. So this is 12 inches per 1 foot. So this is squared kasi naka-square yung inch doon sa baba. So V is equal to, you solve this, ang unit niya is cubic feet. So the final answer is 285.89 cubic feet. So this is the final answer for this number 9. Now we are down to our last problem, guys. So this is an air bubble rises from the bottom of a well where the temperature is 25 degrees Celsius to the surface where the temperature is 27 degrees C. Find the percent increase in the volume of the bubble if the depth of the well is 5 meters. The atmospheric pressure is given by 101,528 pascals. So what is the percent increase in the volume of the bubble? So let's just first illustrate the figure para mas maintindihan natin siya. So this is the illustration of the figure. So an air bubble from the bottom, nag-rise siya to the surface of the well. The well is 5 meters deep. Okay? So yung surface natin, ang properties dun sa surface natin is atmosphere. So that is the pressure natin is 101.528 kilopascal or 101,528 pascal. Then yung ating temperature sa surface is 27 degrees C, wherein sa bottom that is 25 degrees Celsius. So dito sa problem na to, hinahanap natin is the percent increase in the volume of the bubble if the depth of the well is 5 meters. Okay, so yung ating basis dito of course is the initial volume. So if V1 is the initial volume, then V2 is the final volume, yung volume ng bubble dito sa surface niya. The change or the increase of volume is given by, so yung change of volume is given by V sub 2 minus V sub 1. So yung difference of the volume. Now dito sinasabi na find the percent increase in the volume of the bubble. Okay, so yung percent increase is on the basis of your initial volume. So yung percent increase is just equal to your change of volume divided by the initial volume. So i-times 100% natin yan. Para ang unit niya is in percentage. So we need to find this V sub 2 and V sub 1 to find that percent increase. Now, in order to do that, hanapin muna natin yung ibang properties na hindi given. From the combined gas law, we can say that P1, V1 all over T1 is equal to P2, V2 all over T sub 2. Okay. So, we can find its V1 in terms of V2. Now, yung pressure 1 natin, pressure 1. So, pressure 1 is the pressure at the bottom of the well. So, yung pressure 1 natin is equal to the atmospheric pressure plus the gauge pressure. So, yung gauge pressure natin is the pressure due to the height of this fluid. So, we will just add the pressure of the atmosphere, then the pressure exerted by this fluid in order to find the pressure at that bottom of the well. So, that is atmospheric plus gauge pressure. So, yung atmospheric natin is 101.528. I-convert na natin to kilopascal. So, divide by 1,000. So, this is kilopascal. Adding the gauge pressure because of that height. So, density GH. So, recalling our thermodynamics, density G is just your specific weight. So, we can just change this to a specific weight of that fluid. So, in this case, water yan. So, the pressure at the bottom is equal to atmospheric pressure, that is 101.528 kilopascals plus specific weight of water is 9.81 kilonewtons per cubic meter times height niya na 5 meter. So, yung unit nito guys is kilonewton per square meter or kilopascal. So, i-convert natin. So, 1 kPa per 1 kilonewton per square meter. So, kilopascal. So, pressure 1 is equal to 150.578 kilopascal. So, from the given, yung pressure 2 natin is just the atmospheric pressure kasi naka-expose siya sa atmosphere. So, that is 101.528 kilopascal. Yung temperature 1 natin, temperature at the bottom is, we have here as 25 degrees C. So, 25 plus 273 to make that absolute pressure na Kelvin. So, this is just equal to 200, we have here 98 Kelvin. Then, yung ating temperature 2 is 27 degrees Celsius. So, add tayo ng 273 to convert that to Kelvin. So, that is just equal to 300 Kelvin. So, using the combined gas law, so P1 V1 over T1 is equal to P2 V2 over T2. So, hanapin natin yung V2 in terms of V1. So, V sub 2 is just equal to P1 V1 over T1 times T2 over P sub 2. Okay, so input natin lahat. So, V sub 2 is equal to, so 150.578. So, that is in kilopascals. So, times V1. Then, T sub 2 natin is 300 Kelvin. Okay, so we have here all over. T sub 1 is 298 Kelvin. Then, yung P sub 2 natin is 101.528 kilopascal. We can relate V1 and V2. So, this is in terms of V1. So, V2 is 1.493 of V1. Okay, so it's almost 1.5 of V1. So, we can say that our percent increase, so percent increase is your change of volume divided by our initial volume. So, change of volume is just V2 minus V1. Okay, so this is, kung percentage, i-multiply natin sa 100%. So, this is, yung change in V natin is V2 minus V1 all over V1 here times, we have 100%. So, the percent increase of volume is equal to, so we have here V2 over V1, so minus 1. So, i-divide na natin yan. So, times 100%. Okay, from the relationship, V2 is equal to 1.493 of V sub 1. Okay, we just need to input that here. So, percent of increase of volume is, so V2 natin in terms of V1, that is 1.493 V1, so all over V1, so minus 1. So, this is times 100%. So, percent increase natin is equal to, we have here 1.493 minus 1. So, that is multiplied to 100%. So, 1.493 minus 1, this is, so yung percent increase natin of volume is 49.3%. So, that is our final answer for this particular problem. So, that's it guys for today's video. And mahaba-haba yung nasolve nating mga problems and medyo marami yung example na na-discuss natin. I hope that you have understand the concept as well as the process of solving. Thank you guys for watching this video, and kung bago ka sa channel na to or kung hindi ka pa nakasubscribe on this channel, please do click the subscribe button guys para ma-update ka sa mga future videos ko parehas nitong video na ito. So this will be helpful for all of you, especially sa mga engineering students that are taking up thermodynamics. So ito guys, na mga topic na tong dinidiscuss ko dito, this is a very important na fundamentals for you to actually solve more difficult problems. So ang advice ko lang guys, solve. Practice more in solving problem. So that's the secret on how you can master all of these topics. Thank you guys. See you. God bless you all. Thank you for your support to this channel. God bless guys.